talk about JavaScript. All right, so JavaScript is a programming language, and it's mostly used or most famous for being the programming language of the web. Right? It's been around, since very early on when Tim Berners-Lee came up with the World Wide Web, and Netscape started to look for ways to compute the user interface, right, and in the browser, right, to be able to run code inside of the browser and be able to manipulate the user interface, right, programmatically. And at first it was folks got to push back on this idea, right, that this executable JavaScript was going to be downloaded from another machine, right? And then it would execute in your local browser. And folks were concerned about this, right? And some folks would disable JavaScript on their browsers. But since then, the language has evolved quite a bit in browsers as well to address some of those security concerns. So, for instance, any code that executes in your browser, it does it within a sandbox, right? That it cannot exit the sandbox, this security software sandbox that doesn't allow it to access the file system, doesn't has limited access to the network, right? But mostly it cannot go through any of your private information. So the way it was envisioned is that you would there was introduce a new type of element called the script element, where you can embed inside executable code, right? That would be a script using a script language, JavaScript, that would be executed by the browser, and then the browser would be able to interact with the user. So here's an example, a trivial example where we are popping up an alert box, right? That says hello world. So you have an opening script tag and you have a closing script tag, right? And in there you would have your code. So let's go through some of the syntax of JavaScript. This is all very low-level JavaScript, and that's it's very rare that you would actually write a low-level JavaScript, but nevertheless, it's always important to know where things come from, right, and what the browsers actually understand. Now we are going to be coding in React, right, and React doesn't use this low-level JavaScript, right? Although you still have access to it, we don't directly use it. Instead, we rely on compilers, right, that convert React.js. Let me move this slide around. Maybe it's better up here. So we using React.js, we're up here, right? We write our code using this more modern version of JavaScript called TypeScript. Right? Now, this is a language that is not understood by browsers. Browsers only really understand is JavaScript over here, component.js. So we use React to interpret that TypeScript, right, to compile it down to and convert it into a version of JavaScript that browsers do understand, right? And so it's not really it's not a compiler. It's converting between two versions of scripting languages, right? One is a higher level, right, that allows you to do imports, right? Do things that the JavaScript language doesn't support. Well, ES6 does, but browsers only understand very a more less sophisticated version of JavaScript. It is converted into a version of JavaScript that is understood by most browsers, right? And so that it's a very verbose. It's it doesn't have any of the great features that you would find in TypeScript. Also, the TypeScript version that we're using is a version that can be mixed in with XML or, in our case, HTML. So definitely, it's not a version of any programming language that browsers understand. So React does the conversion of this high-level modular component-based programming into a much lower-level version of that, which gets loaded or linked in from an index file, an HTML index file, that is what the browser actually renders. So the browser really cares about an index file that loads your JavaScript. But we are way up here, right? That we're converting through this several layers of abstraction into a lower level version representation of the same code, right? But it's understandable by browsers. So let's focus our attention at this lower level JavaScript, right? And this will be more or less the only time where we will have a chance to talk about low level JavaScript and then never again, right? But nevertheless, it's if not for just historical purposes, it's important to understand what's happening behind the curtains. Right. So we have let's go through some of the more common mechanisms of using plain JavaScript. Here we have a function alert that allows you to pop up a dialog for a user to interact with. Or you have console log that allows you to write to the console of the browser for debugging purposes and things like that. And now this is still accessible. We still use this within just regular TypeScript, right? But before TypeScript, one of the ways that we could create dynamic content programmatically is to use the document object. So document object is it's a global object that is available within the browser executable that gives you access to the document object model. Right? So when you inspect a web page, right, this data structure here, this is the DOM, which is used to represent and draw stuff on the screen. Okay, and so browsers give you access to this data structure so that you can delete from the data structure, create elements in this data structure, right? And as you write and create these pieces of content, you are basically writing to the screen, right? So document is a representation, a reference, right, into this data structure, and it has a whole bunch of functions, right, or it has an API, right, a family of functions that allow you to manipulate this data structure. So for instance, the write function allows you to add new elements to this data structure. Right? You can write plain text, right? Or you can write formatted HTML, right? A header, a paragraph, okay? Which we'll see in a minute. And so when you write this, right, you are adding content to the DOM. Okay. So whenever you see that any of these components that are drawing stuff on the screen using React.js, behind the scenes, this is actually what's happening, right? We are writing stuff to the DOM, right? Also, not only can you write to the document, but you can also read from the document. Right? You can retrieve information from the data structure. Right? So, for instance, if there are elements in the data structure in the DOM that have a particular prime ID, a unique identifier, you can tell the DOM, hey, go and look up, traverse the data structure and look for an element whose primary key is hello. Okay? And then this gives you a reference to that element when it's found. So it does breadth first search, right, in this hierarchical tree looking for this element. When it finds it, gives you a reference. Once you have a reference, you can then manipulate that element that comes back. For instance, one of the things that you could do is to write into it, right, other new content. Right, it might have already content, but you can overwrite it. Right, you can read it. Right? You can edit it. Here, for instance, we are editing the inner HTML, right? So we are inserting new content, by assigning it, to this inner HTML. Here we're saying, plain text like hello world, but it could be HTML as well. You can format this as a paragraph, right? And then this would be formatted as a paragraph. Okay. So here's an example of an element whose ID is hello, right? And then from JavaScript, we can retrieve that element by its primary key. And then once you have a reference to it, you can assign it to a local variable, right? And then manipulate it. So the element right now references that header, right? And then you can use code to then do additional manipulations on that element. For instance, you can use now the element as a reference to change the look and feel. For instance, there's a property inside of the element called the style property or attribute, right? That allows you to then change all sorts of CSS styling. Right? For instance, you can change the foreground color, you can change the font size, right? And notice that these names, look, they are JavaScript names. See that? They are the properties that you would expect when we are manipulating CSS using the style attribute in TypeScript, right? Which is camel cased. Right? And you can hide stuff or you can show stuff, right? You changing the display, none, or block. Okay. Also, you have all sorts of new data structures, right? Other than just plain old strings, you have dates, right? And these data structures in dates allow you to retrieve the month, the year, the day, right? Weeks, and so on and so forth. You also have data structures such as arrays, right? That allow you to collect elements of the same data type, or even diverse data type. Here we have an array of only numbers, but as JavaScript is untyped, you can mix and match. Not in TypeScript. TypeScript does want you to be a little more rigorous about the data types in an array. Here is we're just displaying the array on the screen. Here's just an example of how you would go about rendering dynamic content. So for instance, if you have that array of scores, right, you can iterate over it, right, using a loop, right, maybe calculate the total and then calculate the average. And then you can use document write, right, to write to the screen, right, that the total is some total here and the average is some computed value, right? Or even better, right, you can create more complex representations in the user interface where you can create formatted content, like write an opening UL, right, with always remembering to close that UL, right, and then use for instance LI, right, to display the various scores. You can say scores sub 0, sub 1, sub 2, and so forth, right, and then display the actual score and then close the LI. So here's an example of computing the user interface, right, what's being rendered on the screen using an algorithm, right, based on some data structure. The data structure here being a simple array, right, and then some function that has an algorithm that renders this data structure, converts it into an equivalent list. Okay, so here's an alternative way to render the same data. Right? So the first one was using a list, whereas in this one, right, we're using a table. So we're opening a table. As we iterate over the scores, we open up a row, right, and then create a column that allows us to various columns that allows us to display the scores and the actual values, and then we're accumulating these strings, right, that represents columns and rows, and then appending them to have one long string that is formatted using HTML that then gets written to the DOM, right, and then it would render as a table, right. Also, we are going to introduce the capability of being able to not only generate and calculate content, but also consume events, right? As users interact with the user interface, they can type, right? They can click, they can drag stuff around, and so we need to be able to be notified when these events occur. So, for instance, JavaScript declares attributes or properties that allow you to associate various events with some event handler. So here we have the onClick attribute, meaning if anybody actually clicks on the button, it will invoke this function, right? And so here's a function, say hello, which is just alerting hello, right? And then you would click on it, right? And so other noteworthy aspects is that typically the script tag, the proper place to put script tags in raw HTML documents is in the head, right? So remember that an HTML document has a head at the top, then has a body. Those are the only two sibling elements. Well, the scripts actually go in the head. That's where they go, right? And nevertheless, you'll find very often that developers will put the scripts at the end of the body, right? So here, for instance, instead of being in the head where they belong syntactically, the browser also allows you to put it, at the end of, well, anywhere really, but in particular at the end of the body. And the reason for this is that oftentimes, these scripts might be too long, too big, and if they are towards the top of the DOM of the document, they will load before any content gets drawn on the screen. So this is the content that gets drawn on the screen, and so if these scripts are big, right? You might spend a half a second or a second, downloading this, and if you have not only just one script, but you might have many libraries that you're downloading, it might slow down the time that it takes you to draw something on the screen. So a good practice is to always put it at the bottom, right? So that you're sure that you're going to pump out as much content as possible, as quickly as possible. Put something in front of the user, to capture their attention, and then slowly load the rest of the content. So here's an example of using inner HTML to be able to update the content of the DOM, right? Where we're retrieving some element from the screen, right? And then we are updating that content. So for instance, here in the HTML, we just have a header, simple math, 2 + 2 is equal, and then put a placeholder that's empty with no result, but then use JavaScript to come back, right? And then calculate the values and update the elements, right? And we'll display on the screen. All right, so other things that we'll learn today, with JavaScript is being able to read content that the user generates, right? As they fill forms, and click select element options from a drop down, and then and fill out a form and then submit it. Is that we need to be able to read the elements from these form elements, right? So we can give those form elements some unique identifiers, which we can then retrieve, right? Once we have a reference to it, we can read the value of that element. And here we're just alerting it. So here's a really trivial calculator, right? Where we have a header, a couple of input fields, where we're going to type the values of A and B, right? And then we're going to display the value of the result in C. And then here we have a button that, if you click on the button, it will add A plus B. Okay. So here's a function, A plus B. It will first get a hold of the value in element whose ID is A and also B. Right. Now these are always strings, right? Elements in or anything you type on an input field, right? They will be strings. So we need to convert them, especially if we want to treat them numerically, we need to convert them into integers or floating point or doubles or whatever. Once we have those values, we can then calculate the arithmetic addition of a plus b and then display in the span, the C span, right? Display the value of the addition. Right. So, So we've talked about simple primitive data types, integers, right? Strings, whatnot. We've also talked about arrays, to be able to collect multiple values. We also have objects, right? And so in JavaScript, we call them JSON, right? That it's a notation that is specific to this language that has a syntax of having opening and closing curly brackets, and then properties in those curly brackets with their respective values. Right? So, for instance, we might declare a variable here or constant house that has 3 rooms, 3 baths, right, and 1,300 square feet. Right? And then once you declare these variables, you can use, for instance, dot notation, right, to be able to retrieve the values that you put in the object. So if you put this house here, then house.rooms, you can display that. You can say localhost, right, house.room, and it'll display 3. This is an example of retrieving that, right, and maybe displaying it in the in a UL. We can read the data structure, get a hold of the elements by their IDs, and then fill them in dynamically, right, using the dot notation. So get a hold of the elements by their ID, right, and then we're going to update the values with house.rooms, right, house.baths, right, and so we are updating those all on the fly. Okay. All right. All right. So let's practice a little bit, right, writing some JavaScript. Right. Obviously, we are already using TypeScript, right, but mostly the code that we've been writing is just focusing on the HTML side. So now, starting today and for the rest of the semester, right, we're going to focus more on, writing algorithms, using JavaScript to write algorithms, functions, right, reusable modules, parameterizable data types, but in the context of drawing things on the screen. In the second half, we'll still be using JavaScript, but for being able to retrieve data either from a file system or a database. So let's talk about the labs. Okay, so first of all, let's create a lab 3 component or screen where we can do our work. Let's see, under labs, we have lab 1, lab 2. Let's create a new one. Let's copy that. And let's create a placeholder for index.tsx. There we go. And then let's load the labs so that we can add this new lab 3. Okay, so it looks like we already have a placeholder for lab 3. All right, so right now it's just hard-coded lab 3. Okay, so let's fix that. And so let's load the real lab 3 component that we just wrote. So lab 3. Okay, and then in lab 3, we're gonna be working through several exercises. Okay, and we wrote it. We already had the lab 3 in our routes. Oh, also notice that the route, I'm gonna add a star here because actually lab 3 is gonna have its own routing. So let's add a star in there. Perfect. Okay. All right. All right. Any questions so far? All right. All right. So let's talk about working with variables in JavaScript. Right. So JavaScript has evolved over time. Right. Has gone through several revisions, and there are some some modifiers, some types of variables that have been around, since the inception of the language, right? And var has been typically, historically, the way to declare variables. And but there, in the latest revision in 2015, there were several versions of new types of variables, right? That are much better than the legacy var, right? And so var has kind of fallen out of favor, and instead we are going to be sticking to these two new ways of declaring variables and constants. To declare a variable, right, that's going to change over time, we're going to use the keyword let. Whereas, if something is going to be constant, it's not going to change, then we use const. But we're going to stay away from var, right? You'll still find it in maybe documentation that's a little bit older, right? And so, but nevertheless, stay away from it. Also, other types that we're going to be using is the JavaScript object notation, right? That allows you to declare variables or constants, right? Identifiers that using the curly bracket can define a hierarchy of properties and values, right? So for instance, here you have the opening and closing of the curly bracket. And then in there we have properties, an object property, a number array property, and an object array property, right? And each one in turn, right, an object property is in itself another object in there that has some properties that are arrays. For instance, this is another array property, and this is another object property. And then finally, you have actual data, right? You have, for instance, another object property is an object that has properties Q and W with values 111 and 222, right? Or a number array property that has numeric values 1, 2, and 3. Okay, and you can use dot notation to be able to navigate through these data structures, starting at the home object being the root, right, and using dot notation to go into each one of the properties. Here, we're retrieving the second array, right, of another array property inside of an object property. So this one right here, second one, 0, 1, 2, that one 5, 4, 3. So there it is, 5, 4, 3. So object notation, JavaScript object, they're going to be using that quite often throughout the semester. Right, as I mentioned earlier, right, there has been some iterations in the languages, in particular, going from ES5 to ES6 in 2015. It's been a while. It was 9 years. And but it is important to point out, since there are still some legacy code that's still out there, right, that it's important to be able to read it. Why was it like that, and how the current version is so much better. So for instance, before we would use variables, var, whereas today we use let or const. Right? And for instance, before you could not use declare variables inside of your for loops, whereas today you can. For instance, you can declare I inside of the for loop, very much like modern languages, right? And also today, these variables, you can declare them inside of a code block, and then they would lose any meaning outside of that code block, right? So it's scoped to that particular code block, which is very good. All right, so let's take a look at some examples, exercises to practice variables in JavaScript, right? So the labs are going to ask you to create several of these components, right, and then include them in the labs index file. So let's do that. Let's create here in lab 3. Let's create a few of these, just to practice, constants and variables, and it'll give us a chance to discuss, this topic. All right, so we have that, and let me just include it in lab 3 so we can follow along. So this is variables and constants. There we go. There we go. And let me close that. So basically, variables and constants is just something simple that allows us to we're declaring all three, var, let, and const. So var is still supported, for backwards compatibility, but we should stop using it. Instead use let and const. One of the weird things about using variables is that you could use a variable that hasn't been declared and then declare it later, right? And so that creates all sorts of problems. And whereas the new keyword let doesn't do that, doesn't allow you to do that, right? You have to first declare it before you use it. And so here we are declaring this variable, this let, right? And then we're computing some simple arithmetic here. Just to point out the fact that when you want to display the values, right, in your HTML snippet, right, you use the curly brackets, right, as an escape sequence, right, to be able to embed a variable, right. So notice that if I this over here, right, is being rendered as function scoped 2, right. So this is function scope 2, right. So this here is being replaced. Oops. This here is being replaced by the actual value 2, right? Notice that if I don't have the curly brackets, then this would be literally the text, function scoped. But if I put curly brackets, then this is understood as being a variable, right? An expression that needs to be evaluated, and then the equivalent is a string, right? Is then replaced and rendered onto the screen. Make sense? Same thing like any calculated value, or this could be a function, a function call. Okay. All right. Let's go on next. All right, we did that already. Okay, so variable types. There's a quick overview. The fact that we have multiple data types. So export default function variable type. Oh, actually, I have the code here. Let me copy that. So here we have a number, right? Floating point, string. Now, by default, JavaScript or TypeScript in this case, right, is JavaScript is an untyped language. And actually, that's not that untyped, but it's that you don't have to declare the types. Right? The types of the variables are declared at runtime. Right? So when this runs, right, it will know, right, that this is an integer, right, because it's being assigned to an integer. It will know that this is a floating point because it's being assigned to a floating point. This is a string, boolean, blah blah blah, all these, right? And for the most part, it works fine. The problem is that when you assign a variable to another variable, right, and then different variables are of different types. You also can query a variable to ask it what type is it, right? And so for using the operator type of, right? So this returns a string, right? That telling you whether this is a number, string, or boolean. So here, what we're doing here is that we are then rendering the values. Number variable is 1, 2, 3, 1, 2, 3, 4 strings and whatnot. But I just want to point out this over here. Notice that the boolean, right? We could have, it says, well, for all the other ones, we were just doing just plain old curly bracket here. But here we took care to concatenate it with an empty string, right? And the reason is that boolean variables, right? They are not rendered. They don't modify the DOM themselves, right? They have no representation, unless what we're doing here is that we are forcing it to be converted into another data type, a string. And then you would see true, false, the value true or false, right? But notice that true is not the string true, and false is not the string false, right? Only when we are coerce it into a string, then it becomes an actual string, right? And that will become very important a little later when we look at if statements and booleans, right, and all sorts of boolean related expressions, right? So let me import this into the lab 3. So variable types. Okay, there we go. So notice that indeed the Boolean is rendering as true. Right? But notice that if I remove the string here and just save like that, notice that it doesn't render. See that? And that's actually very important that it doesn't render, right? And we'll see why in a minute. Right, so, but here I do want you to see it, that it is the value true, okay? Also notice that is number, right, gets a string representation of whether it's the actual type. This evaluates the type either as a string, number, string, or Boolean, or object, or function, okay? All right, let's take a look at another example, Boolean variables. Okay, let's see, Boolean variables. Let's create that. That's this file, so we can play around with Boolean values. And okay, so this does not have the export here. So export default function, right? And then let's close this here. Very good. And let's import this into Lab3 so you can see what this does. Boolean variables. There we go. Okay, so what does it do? Okay, so it's just displaying a whole bunch of Boolean variables and their actual values. And this is so that we can introduce a few things. Here we are declaring two numeric values, right, and a couple of Boolean values, right? True 1 is equal to true, false 1 is equal to false. And then here we're introducing the AND operator, the Boolean AND operator. So true and false gives you false, right? So that's correct. And then here we're introducing the Boolean OR operator, right? That, true or false gives you true. Very good. And then we have the not operator, right? So not false is true. Okay. Then here we're also introducing the triple equal sign, right? As opposed to the double equal sign. Okay. We have the single equal, we have the double equal, and the triple equal. The single equal is used for assignment. And the double equal has fallen out of favor, right? But it's still valid. You can use it, right? And so we can say we can use another one. True 6, right? Let's call it false. False 3. And we'll say, oh, we have false 3 already. So false 4. And we'll say that 2, 3, 4, is it equal to 1, 2, 3? All right, notice that it's complaining. Right, notice that it's complaining the double equal. All right, and obviously this is not, it's not equal, and it's already telling us that we can't compare it. All right, so let's use a number variable, and let's do 2, 3, 4, so that we get a false. Okay, here we go. So we're checking to see whether 1, 2, 3 is equal to 2, 3, 4. But notice that we're using a double equal as opposed to a triple equal. See that? All right, and let's actually print it out. Let's print it out. So we'll print it, let's see, true 4. Here we'll display it right before, false 4. There we go, like that, false 4. Notice that it returns as false. So the question is, well, why are we using double equal as opposed to triple equal, right? They both work just fine, right? Now, the reason is that the double equal, right, allows you to it allows you to compare things that are not of the same type. Here, number variable is integer, and this is an integer. And it makes sense to compare integers and integers. But notice that the double equal would allow me to also compare it against a character. Now, this is my IDE, warning me of this, right? But the JavaScript language would be perfectly fine with a double equal, right? Comparing characters, right, and numbers, and then what the double equal would do is that it would coerce one of the sides to the other, right? To try to convert one of the sides to, for instance, an integer, right? Try to parse it and convert it into an integer, and then do the comparison. Okay. Now that leads to very weird results, right? Unexpected results, and it's very buggy, right? It's very hard to find the case where you are comparing things that are not comparable, right? So folks have abandoned the use of the double equal, right? Since yes, it works when you know that things are the correct data type, the same data type, but you could inadvertently assign it, right? And also IDEs today will catch this, right, and will warn you like it did here. We no longer use the double equal, right? Because again, it could introduce these buggy things, these buggy errors that are hard to find. So instead, we prefer to use the triple equal. What the triple equal does is that it first confirms that both sides are the same data type. If they're not of the same data type, it won't even bother to compare them, where it will evaluate to false. Okay, so as a good practice, don't use the double equal. I mean, your IDE won't let you, and also React.js won't let you. But if you are ever writing just simple JavaScript, just don't use the double equal. Use the triple equal. Here we have the not equal. Again, with the double equal, there is a version without the double equal, right? Which works also as well, but that has the same flaw, right? That allows you to compare things of different data types. Whereas with a double equal like this, then it first checks the data type. Okay. Also, you have the various greater than, less than, right? Greater than or equal. All those are still available, right? So this is just to introduce the various comparison and Boolean operators. Okay. All right. Let's go on. Let's talk about conditionals. Actually, no. Let me talk about the ternary operator. Let me create a file for this. Oops. Ternary. There you go. And we'll need a file. So export default ternary operator, return. Oh, wait a minute. Paste this. Okay. All right. What am I missing? Oh, yeah. Okay. All right. So let me show you this. Let's import this over here. So this is a ternary operation. Wait, is that what I called it? Ternary, ternary. Oh, ternary. Ternary operator. There we go. Okay, let me display here. Okay, welcome, logged in, right? So let's take a look at this. Okay, so notice, right, that here we have a Boolean variable saying logged in, true or false or whatnot, right? And notice here we have logged in, and notice this expression right here, right? So this expression, notice that it has a question mark, which is basically evaluating the left-hand side, on whether this evaluates to true or false. Right now, this is a simple Boolean variable, but it could be a very complex expression with ands and ors and nots and parentheses and whatnot. Just a Boolean expression calculating whether this is true or false. Then this right decides on whether it is true or false, and depending on that value, this whole expression will either evaluate to two options. One option and then the other option. And those two options are separated by a colon. Right? Let's see if I can make this read a little better. No. So if this is true, right, then this whole thing evaluates to the first expression over here. Now, if this is false, then this whole thing evaluates to the second expression here, right, separated by the colon. Now, because logged in is true, right? This is true, then that means that this whole thing evaluates to a paragraph that says welcome. There it is. See that? Now, if this is false, right? Notice that this renders as please log in. See that? Right? So again, here you can create complex user interfaces, right? That either render one way or another. Now, here we are just displaying simple paragraphs, but this could be either a another component, right? That it's implemented in a separate file, right? That you've imported over here, and then you either display that or display the other. Okay, and again, this expression can be arbitrarily complex. Okay, so yeah, ternary, very important. So that allows us to do all sorts of very interesting user interfaces. And yeah, okay. So here, there's a conditional here. I'm gonna put it in the same place. I'm gonna copy that. Yeah. So this right here. So let me have. Do we have true? Okay. So notice that we have true here. Let me copy that and we paste that in there. Okay. And let me have the if else here. I'm gonna copy this over here. Let me show you this. Okay. Okay. So notice that here we have the if else header here, and notice that this expression is a Boolean expression. See that? Notice the and in between here. So you have the left-hand side, which is clearly a Boolean variable, right? That has been initialized to be true. So this true is being ANDed with something that is not a Boolean expression. See that? What's happening here is that when we combine, right, this Boolean expression between something that is Boolean and something that is not Boolean, what happens is that this evaluates to either an empty content or the actual content that you have here on the right-hand side, based on whether this is true or false. So if this is true, this whole thing evaluates to the paragraph. If this is false, then this doesn't evaluate. It doesn't show at all. So notice that it's now showing true 1 here, right? But if we say false, notice that it disappears. It's gone. Not there anymore. And that's why this is achieved by the fact that this the Boolean variable is not rendered. It doesn't. This is where I mentioned earlier, right? That the importance that Boolean expression or Boolean variables, right, don't actually get rendered on the screen, right? That you would have to force it by concatenating by something, right? So that you coerce it into that other data type. Here, basically, the whole thing is being coerced into a HTML code snippet, right, that evaluates to that, right, or it doesn't evaluate to anything. So depending on whether this is true or false, you render the right-hand side, right? And this is going to be, a very important strategy that we're going to be using throughout the semester, right, to either show something or not. Right? Later on, we'll be able to control this Boolean expression by, perhaps clicking a button, so that would allow you to toggle this content, right? Maybe represented as a separate component, right, or some embedded snippet in here, right? And by toggling this true false, right, we can hide and show this content on the right. Okay, very important feature. Okay. All right, so here we have another of taking a look at conditional output. So let me copy that. Also, this is going to allow us to introduce a new syntax for declaring our components that we haven't seen before. Okay. Now notice the change in syntax here. Right. Notice that here I'm declaring a constant, and it's being assigned something that we haven't seen so far. Right. So basically, on the right-hand side is a function declaration. Here we're declaring a function and that function gets instantiated, an instance of that function gets instantiated, and it's being assigned. See that? It's being assigned to this constant. So this constant now is not of type integer or Boolean or string, is of type function. Right? So this constant now is of type function, which can be invoked. Right? Just like integers can be added, right? And Booleans can be ANDed or not or ORed, right? And strings can be concatenated. Well, a constant of type function can be invoked, right? And that's exactly what we're going to do. So basically on the right-hand side is we're introducing a new syntax for declaring functions. It's called the arrow function syntax, okay? Because of this arrow here, right? And so this new syntax, we'll see in a minute, with much more detail, but it's a much more compact syntax, right? That is going to have, it has quite a few new features, right? That are really, really exciting. So we'll come back to that in a minute. But basically, we are declaring a function, just like we've been declaring all these other functions. This is the older function declaration syntax. This is a new syntax for declaring functions, okay? And with a whole bunch of new features. All right. So here we're just declaring a function and we are exporting it. Okay? So in this function, we're declaring a constant called logged in, and based on that value, right? Remember, we have a return here. That when we have a function, usually it's the last thing that function does, right? And it returns a code snippet or that contains some HTML. Now here, notice that we have two returns, right? So this function evaluates to either, right? If this is true, then it evaluates to this return. Otherwise, it returns this, right? So the whole thing is actually rendering something. It's either rendering one or the other. Okay. I guess you don't need this else, right? We could have dispensed with the else and just do that. We could have done that. If it's logged in, we do this and we return, and that's it. Or otherwise, we return that, right? But it looks more elegant like that. So let's import our new conditional output if else. So here, conditional output if else. So it says welcome if else. There it is. Welcome. This says welcome if else. But because it's true, since it's true, it's returning this over here. But if this would be false, then it would render please log in if else, right? It's returning this over here. Please log in if else right here. Okay. Yeah. So you can have multiple returns, right? And the whole component gets evaluated to based on some algorithm, some logic, right? Now an alternative way to implement the same thing, let me show you, is to use an inline syntax. Right? So for instance, let's create here the same thing called conditional output, but the inline version. Right? So let's copy that in there, right, and import that into our lab3. Conditional output inline, like that. And there it is. So this is the inline version. Okay, and notice what's happening here is that here we are using the AND operator, right? We're ANDing it with this Boolean variable that it's either true or false. So since we're using two different versions of this, right, where you can either one of them or the other is true, because here we're using logged in and then here we're using not logged in. So that means that only one of these two options will render, right? If this is false, then this does not render, right? This does not render because it's false. But not false, this is true. That means it renders please log in inline. If I turn this into true, right, then it renders the first one, welcome inline, because this is true and this is not true. Okay. So yeah, two ways of doing the same thing, right? This is a little more compact, perhaps a little more easier to read, right, where you have a single return and the logic on determining what to render is embedded inside of the return, as opposed to here, the logic of what to return is outside of the HTML, right, is part of the JavaScript, okay? Let's talk about functions, JavaScript functions. Right, so arrow functions is a new syntax, right, that was introduced in ES6. The language JavaScript, the official name is ECMAScript, not JavaScript. In 2015, there was a huge new version that came out that introduced a lot of new syntax. In particular, introduced this new syntax called the arrow function. Right. So here we have the older legacy function syntax, which is still widely used. Right. We have been using it quite a bit, but you can now use this alternative syntax where you declare a constant and then you assign it a declaration of a function. Okay, and so same thing where here we have arguments a and b, right? And here we have console. So the body is the same. The body is the same, right? But the syntax is a little bit different here. We don't have a keyword function. Instead, the keyword function is replaced by an arrow function in between the parameter lists, right, and the body of the function. Right? We have this arrow that tells us this is a function. So one of the great things about this new syntax is that it's much more compact. So for instance, here we have, for instance, the fact that if the return, right, if your function in the body of your function, you only have a return, then that return keyword is optional. Right? You don't really need it. So for instance, here's a more pronounced version where, so if you have this add E6 ES6, if the only thing you have here is a return, then you can drop the return, you can drop the curly brackets, right, and just replace it with the expression, right, and that's what's going to be evaluated, and that the whole thing evaluates to that value, it returns that value, right. So here's another couple of examples of using the return as being optional, right? So return, we're dropping return the curly brackets, right? But also, right, if you only have one argument, one parameter, even the brackets, the parentheses are also optional. Now, your IDE won't let you; they will force you to put the parentheses in there, but officially, the parentheses are optional. Another thing that also it was pretty big when this new version came out is that now the keyword this behaves as intended, right? The keyword this was not behaving like it behaved in all other languages. It had its own particular idiosyncrasies, and it's not worth even going into it. Now the this keyword behaves. If you use the arrow function, if you use the new arrow function, the keyword this behaves as expected. Other things that are also were introduced in the syntax is that the parameters, now you can give it default values, right? So that if they are not provided when you call the function, then the variables that for which you didn't provide values, right, take on the default values here. Okay. All right, let's talk about, let's create a few labs here. Let's first look at legacy functions, how it used to be. All right, so let's create here a component legacy function. And let's use the old syntax. So here we have a component legacy function, right, that is calling on the functions add that is declared outside that takes two values, a and b. Also notice here we have a declaration of the parameters data types number, right? That is now mandatory, right? Because we're using TypeScript. Otherwise, if we were using just plain old JavaScript, calling a function did not require you to declare the data types of that function. But now with TypeScript, thank God, right? We we have to declare those data types. So here we're calling it with 2, 4, so that becomes 2 plus 4, 6. Right, we're printing it out, but then we're also embedding it. Right, the variable that has been or the constant has been pre-calculated, but also calling that function right from within the nested snippet of code. Right, so let's embed this in our index. Right, so this is a legacy function. So here, legacy function, and there it is. So 2 plus 4, 6, or this one, we are invoking it embedded inside of an escape sequence, right? And this expression is being evaluated to whatever 2 plus 4 is, and that comes back to 6, and that's what gets rendered here, right? So this doesn't need to be just a variable, but it can also be a function call, okay? And let's take a look at the arrow function. So we're going to do an equivalent implementation, but instead of using add, we'll use maybe subtract or something else, right? So let's grab that. There we go. So yeah, notice that in the here we're using the add. We're using the function keyword to declare the add as a function, whereas here we're declaring the subtract function, right? But using the new arrow syntax, okay? And you can use the function just like you would in the legacy syntax. You can just call, just add 2, 4. Here we're just saying subtract 3, 1. So the invocation of the function syntax is just the same, right? And we're just displaying, and then we're invoking the function from within a escape sequence, right? So let's import this here. So this will be arrow function. So arrow functions. There we go. All right. So new ES6 arrow functions, 3 minus 1, and subtract 3 minus 1 is 2. Okay. And then here we have an example, right, of using implied returns. So let's take a look at here. Create an implied return. Oh, we have to create the export default implied return. There we go. And close that. Okay. So what we have here is that we're declaring this multiply function using the arrow function, right? The arrow syntax. And notice that we don't have a return, like return A times B, like we had here, right? In the arrow function, we have a return here. See that? So even here, it's unnecessary, right? We could get away with just removing the return and the curly brackets, and this would work just fine. But here we have an example, right, where here we have just remove the return and the curly brackets, and then we can just call the functions like we would always, right? Multiply 4, 5, and here embed it in the code snippet. So let's bring that in, implied return. So implied return. It works just the same, right? 4 times 5, is